Welcome back, guys. Today's lesson is on rhombi and squares. These are the last two of the parallelogram family that we are studying in chapter 6. So in this lesson, what you're going to see is properties of a rhombus and properties of a square. And we will also look at conditions for a rhombus and conditions for a square. How could you prove that a parallelogram is one or both of those things? Properties of a rhombus. So you can add this to your quadrilaterals family tree. One property comes straight from the definition of a rhombus. A rhombus is a parallelogram with all four sides congruent. So the new thing here is that a rhombus has all four sides congruent. That's the first key property of a rhombus. It's a parallelogram as well, which means, by definition, a rhombus has got all of the properties of a parallelogram plus all four sides congruent, like we just said, as well as some special characteristics of its diagonals. And these can go in your family tree as well. So a rhombus has diagonals that are perpendicular. They always intersect at a 90-degree angle. And the diagonals of a rhombus bisect a pair of opposite angles. So here in our example rhombus, the opposite angles are bisected, which means they're cut in half equally. So angle 1 is congruent to angle 2, and angle 3, and angle 4. All of those are congruent angles because of the diagonals bisecting them. And on the other side, angle 5 and angle 6 are congruent, and angle 7 and angle 8. So all of those are bisected, plus the opposite angles are still congruent to each other when they're bisected because of properties of parallelograms. So there are the key properties of a rhombus. Make sure you get those in your family tree. And here's what that family tree should look like at this point. We've got all our characteristics of parallelograms, rectangles we talked about in the last lesson, and now you have these properties of a rhombus, what makes something distinctly a rhombus in the parallelogram family. So let's practice using these properties of rhombi and find missing parts. So we see where the diagonals of this rhombus are intersecting, and we want to use the given information to find each measure or value. So we're given that the measure of angle FJH, this whole angle here, that whole corner, is 82 degrees. Okay, that's our given. We want to find the measure of angle KHJ, which is this one right here. So it's not the whole corner of the rhombus, but part of it. All right, so what do we know about angles in a rhombus? Well, first we know that the diagonals are bisecting opposite angles. So if angle FJH is 82, that's being bisected by the diagonals. So we can cut that in half to figure out this little angle KJH and use that. So half of 82, angle KJH is going to be half of that 82, and that of course is 41 degrees. So this angle right here, the little one, is 41. All right, so we know that. We also know in a rhombus that the diagonals are perpendicular. So where they're intersecting is a 90-degree angle, which gives us 90 degrees. And if you look, we are dealing with a right triangle inside of a rhombus. There's a right triangle. And we know two of the angles inside that right triangle. We've got 41, we've got 90. So far we have 131 degrees. And of course you remember that the angles in any triangle always add up to 180 degrees. So if we just subtract our 131, we should have our remaining angle, KHJ. 180 minus 131 gives us 49 degrees. So the missing angle KHJ that we were asked to find, that is 49 degrees. And again, you can double check by adding up those three angles, making sure they get us to 180. All right, another use for properties of a rhombus. We can find missing variables using parts that we have. So we are given GH. Let's highlight that, GH. So that's a side of the rhombus. That's x plus 9. And JH, another side, is 5x minus 2. And of course, from the definition of a rhombus, we know that all the sides are congruent. So GH and JH are congruent. They're the same length, which means x plus 9 is equal to 5x minus 2. So we can just set up that equation using properties of a rhombus, knowing that the sides are equal, and then solve for x. To finish off, we divide both sides by 4 to get x by itself. And we've got 11 over 4 equals x, or 2.75 equals x, if you want to write that as a decimal. Either one of those answers works. There's the value of x using properties of a rhombus, or in this case, the definition of a rhombus for congruent sides. All right, now we know that FK equals 5, so that's part of the diagonal. 5. FG, one side, is 14. And we want to find the length of KJ, this part down here. So immediately, that doesn't have anything to do with the other two parts we found. We remember again that in a rhombus, the diagonals are perpendicular, and that forms right triangles for us. So we've got two sides of a right triangle here. We're missing this side. And if we can find GK, we actually have also found KJ, because a rhombus is a parallelogram, which means the diagonals are bisecting each other. So these two parts of the diagonal are equal. So if we can find GK, then we can find KJ. And of course, to find a missing part in a right triangle, we're going to use the Pythagorean theorem. We know one leg of the right triangle and the hypotenuse, and we're just missing that second leg, so we're going to simplify and solve. Take the square root on both sides. B, the missing leg, is the square root of 171, which is approximately equal to 13.07. That's the length of GK, which is also the length of KJ. So there's our missing part. We used quadrilaterals and triangles to find that. All right, your turn to try an example. Use those properties of a rhombus that you've got down in your family tree and solve this problem here. Pause the video, work it out in your notes, and you can check your answers at the very end of the video on the last slide. All right, on the blank page next to your quadrilaterals family tree in your journals, I want you to list these conditions for a rhombi. Give it that header so you know that these are conditions for a rhombus. And then you can just list those or shorthand them in your math journal. But here are different ways to check and see if a parallelogram is a rhombus or not. These are facts that you can use to prove if it's a rhombus or not. So if a parallelogram has diagonals that are perpendicular, we know that that's a rhombus. Or if you can show a parallelogram has one diagonal that bisects a pair of opposite angles, that's enough to show it's a rhombus. We know that both diagonals do that in a rhombus, but as long as you can show one diagonal is bisecting a pair of opposite angles, then that's enough to say that you have a rhombus. Or one other way to prove if something is a rhombus or not, you look at the parallelogram, and if it has one pair of consecutive sides that are congruent, then you can say it's a rhombus. And that consecutive sides is talking about sides that are right next to each other. So let's say you've got a parallelogram and you are given, or you can show that two sides right next to each other are congruent, then that's enough to say it's a rhombus and that all of the sides are congruent. All right, the last of the parallelograms that we're going to talk about, squares, and who better to introduce them than SpongeBob SquarePants. He lives with this shape every day. Properties of squares. So the definition of a square shows us that there really isn't anything specific that we need to add about squares to our family tree, because a square is a parallelogram with 4 congruent sides and 4 right angles. Now we've covered both of those properties before. 4 congruent sides we just looked at is talking about a rhombus. And 4 right angles, look back in your family tree and you should see that that is talking about rectangles. So a square is a cross between a rectangle and a rhombus. So because it's each of those, a square has all the properties of a rectangle and a square has all the properties of a rhombus. And of course, then it also has all the properties of a parallelogram, because rectangles and rhombi are parallelograms. So in your family tree, all you really need to do is just, if you want to draw a square and show 4 congruent sides and show 4 right angles, that's fine. If you want to write, a rectangle plus a rhombus in there, that's fine to give it some written properties. But we don't need to list anything specific because all of a square's properties are already listed under each of our other parallelograms in our family tree. So those are properties of squares. Conditions for squares, this can go again on the page next to your quadrilateral family tree, underneath where you wrote conditions for a rhombi. But basically, to prove if a parallelogram is a square or not, it's a quadrilateral that is both a rectangle and a rhombus. If you can show it's both of those things, then that's enough to prove your quadrilateral is also a square. So let's do a coordinate proof where we put all these properties of parallelograms together, and specifically rectangles, rhombi, and squares. All right, we want to determine whether parallelogram JKLM is a rhombus, a rectangle, or a square, and we want to list all that apply. So not just the most specific one, but any of those classifications that apply to the parallelogram. And the nice thing here is that we're given it's a parallelogram, so we don't have to prove anything about, opposite sides are parallel or opposite sides are congruent, nothing like that. That's given to us. So now we can just focus on, is it a rectangle? Is it a rhombus? Is it a square? So we're using the properties of those 3 parallelograms from our quadrilateral family tree. So let's break this down and go one piece at a time. Starting off, we want to determine whether the parallelogram is a rhombus. So the question to ask here, when you look at your properties of a rhombus, the easiest, quickest thing to show is looking at the diagonals. are the diagonals perpendicular? And on the graph, if we want to figure out if two lines are perpendicular, we need to find their slope and see if they are opposite reciprocals. So our diagonals, if we draw them in, we've got KM is one and LJ is the other diagonal. So we want to find the slopes of each of those. And our slope formula, let me write it here at the top. That's the rise over run. Rise is given by the y's, of course, and run is given by the x's. So we're going to find the slope for each of these diagonals and see, are they opposite reciprocals? All right, so KM, this is like my x1, y1, x2, y2. We're going to plug that in the slope formula. All right, and simplify. -4 minus 4 is going to be -8 over 2 minus 0, which is 2. And -8 over 2, of course, we can reduce to -4. Whoops, -4. So there's the slope of KM. Now let's find the slope of JL and see if we have opposite reciprocals. So now here's my x1, y1, and L is my x2, y2. We'll plug those coordinates into slope formula. 2 minus a -2, remember, is the same thing as adding the positive. And then on the bottom, we've got 9 minus a -7. So both of those we get to change to a plus. And we've got 2 plus 2, which is 4 over 9 plus 7, 16. That reduces to 1 over 4. Positive 1 over 4. And -4 is what we have. Those are opposite reciprocals. We switched the sign and we flipped the numbers. Remember, 4 is the same thing as 4 over 1. So those are opposite reciprocals, which means yes, this is a rhombus. So we got one down. We got to check all the others. We want all that apply. So the next parallelogram to check is it a rectangle? And again, we want to look for the shortest, easiest way to prove if it's a rectangle or not. So looking at your properties of rectangles, the question here to be asking is, are the diagonals congruent? Again, when we look at the diagonals, that gives us just two lines to look at. So if we can prove that those are congruent, then that will help us prove it is a rectangle, because diagonals of a rectangle are always congruent. So here we're going to use the distance formula if we're talking about length. And distance formula is our big square root one. Remember, we're smushing the Pythagorean theorem into one giant step. All right, so if we use distance formula to find the length of both of our diagonals, if they have the same distance, then they're going to be congruent. All right, so let's start with Km, x1, y1, x2, y2. Always good to label those so you keep them straight in your formula. Okay, x2 minus x1, that's 2 minus 0, which is just 2 squared, plus y2 minus y1, -4, minus 4 is -8 squared. And let's finish simplifying. 2 squared is 4, plus -8 squared is 64. And 4 plus 64 gives us the square root of 68. I'm just going to leave it as a radical, even though that's not simplified. We still can compare answers as radicals. All right, now let's find the length of JL, x1, y1, x2, y2. Plug into the distance formula. x2 minus x1 is 9 minus negative 7. So again, that's adding the positive, and that's 16 squared plus 2 minus a negative 2, or 2 plus 2, which is 4 squared. All right, let's simplify here. 16 squared is 256 plus 4 squared, 16. And when we add those up, we get the square root of 272. That is not the same as the square root of 68. So this parallelogram is not a rectangle. The diagonals are not congruent, so it can't be a rectangle. All right, last one to check. Is the parallelogram a square? So again, our condition for a square is the parallelogram both a rhombus and a rectangle? So using that condition, let's review. Is it a rhombus? Yes, we showed that it is a rhombus. Is it also a rectangle? No, it was not a rectangle. So since it's not both a rhombus and a rectangle, this cannot be a square. It's not a square. Only a rhombus. So here's our final answer. Determine whether JKLM is a rhombus, a rectangle, or a square. The only one that applies is the rhombus. It's a rhombus only. None of the others work out. All right, so that's a way to kind of culminate together all of these properties of different parallelograms that we've been studying and prove on a graph whether or not it's all of the above or some of the above out of the rhombus, rectangle, and square. All right, that is it for the parallelogram family. There's still a couple more quadrilaterals we will talk about in the next lesson. But for now, just double check that you got all the notes, you worked out examples in your notes, added the properties to your quadrilaterals family tree and the conditions for those quadrilaterals. And then here's where you can check your work for that last example with the rhombus that you worked out in your notes.